Hello everyone, myself Kalai working as an assistant professor in the Department of Mechatronics Engineering for past 10 years. Today we will discuss three-phase induction motors, which are the most widely used in AC motors in industrial applications. So, introduction to three-phase induction motor. These motors commonly used in pumps, fans, compressors, conveyors, industrial machineries. So, the reason for their popularity are which is simple in construction, self-starting capability compared to the single-phase induction motor is not self-starting, high efficiency, low maintenance cost, good speed regulations. So because of these advantages, three-phase induction motors are called the workhorse of industries. Um, Now let us start with the construction of the motor. Before that, we are processing this topic in a design thinking process. Empathize, define, ideate, prototype and testing. So for this empathize, let us understand the need of this motor. So that is we are previously seen, and then in this basic construction we define the motor. So the three-phase induction motor mainly consists of four important parts, that is stator, rotor, air gap and then bearings and frames. So stator is a stationary part of the motor which consists of laminated steel core with three-phase windings, and then the rotor is a rotating part placed inside the stator. It rotates due to the electromagnetic interaction with the stator field. Air gap is nothing but a small uniform air gap exists between the stator and then rotor, which allows smooth rotation and magnetic interaction. For this bearing support the rotating shaft and reduce friction. The frame protect the internal components. First one is stator construction and winding. The stator consists of several components. The stator core made up of laminated steel sheet. Lamination reduces the electric eddy current loss. And then the three-phase winding is nothing but the three windings are placed 120-degree electrical apart. These windings are connected to the three-phase AC supply, and it also having the slots which are provided in the stator core to house the windings securely, and then terminal box which produce the external connection to the three-phase supply. For this rotor construction, here we are using screw cage and then slip ring. So there are two main types of rotors used in the three-phase induction motor, which consist of aluminum or copper bars. Bars are short circuited by end rings, so it is very simple and robust construction for the lowest maintenance. So this is the most commonly used rotor. And then slip ring rotor has the three-phase windings which connected to slip rings, and then external resistance which provides the high starting torque used in cranes, elevators and then mills. The operation of a three-phase induction motor is based on the rotating magnetic field principle. When a three-phase AC supply is applied to the stator winding, a rotating magnetic field is produced. The magnetic field rotates at a synchronous speed. The rotating field cuts the rotor conductors. So according to the electromagnetic induction, the current is induced in the rotor. So interaction between the rotor current and magnetic field which produces the torque. So this causes the rotor to rotate in the same direction as a rotating field. There are two main types of three-phase induction motor, that is squirrel-cage induction motor, another one is slip ring induction motor. The squirrel-cage induction motor is a simple in construction and low cost, very robust and low in maintenance. And this squirrel-cage type is mainly used in the applications like fans, pumps and then blowers. So second type is called slip ring induction motor, which is high starting torque, external resistance control, and then suitable for heavy load applications like cranes, elevators, and then rolling mills. this is a equivalent circuit. This equivalent circuits helps analyze motor performance. So important components includes R1 and then X1, that is stator resistance and reactance, and then XM is called the magnetizing reactance. R2 dash and X2 dash is called rotor parameters refer to stator, and then R2 dash of 1 minus S divided by S is mechanical load equivalent. So this circuit is similar to the transformer equivalent circuit. And then it has the important performance characteristics or the performance parameters includes the efficiency, power factor and speed regulations, with the power losses. So efficiency of three-phase induction motor have high efficiency, that is 80 to 92 percentage, and power factor is typically 0.8 to 0.9 at full load. Speed regulation is very good compared to the single phase induction motor, typically 3 to 5 percentage, and power losses, which includes the stator copper losses, rotor copper losses, copper core losses, and then mechanical losses. The torque speed curve describes motor behavior. The main key points includes the starting torque about 1.5 to 2.5 times of the full load torque. So the maximum torque about 2 to 3 times full load of torque is called as pull out torque. That is, it is also known as breakdown torque. The operating region of motor normally operates close to synchronous speed with a small slip. This ensures a stable and efficient operation. This is the mind map of three-phase induction motor, which widely used in industrial pumps, fans and blowers, compressor, conveyor, and then machine tools. They are the most important used motors in the industry application. So this is a final stage of recap and summary. Let us summarize the three-phase induction motor, which are widely used in industries. They operate on the rotating magnetic field principle. The main parts of this three-phase induction motor, which includes the stator, rotor, air gap and bearing. Slip is essential for torque production. They offer high efficiency, reliability and lower maintenance. Thank you.